Welcome to our new Plasmalab. Here we're going to show you actually 3 different stages of our research towards the plasma technology. Gerard, maybe can you take over for the first step?
So it's my pleasure to demonstrate to you our plasma. This is a microwave plasma setup where we are able to really look inside the plasma at what is happening. And Tim, can you please make us some plasma and tell us about what you are doing?
I'm currently making a plasma using microwaves. These microwaves are very similar to the microwaves that you have at home, but instead of putting these microwaves in a big oven, we guide them through these tubes and we focus all the energy at a single line, and at this single line we feed a gas through it so that we can do exciting plasma physics.
Perhaps we have here Tim and Tom. Tom, can you tell perhaps a little bit about what you are going to do scientifically here?
The plasma that we create here, it more or less behaves in a similar way to the arc plasma that we build next door. So that, what I mean by that is that the chemistry is driven by the high temperature. But the plasma that we make here is more accessible, so we can use this laser, for example, fire it into it, and we can really study what's happening. We can watch the chemistry taking place, we can watch the evolution of temperature, and we can really get a fundamental understanding of what is going on.
Thank you, Tom. Thank you, Tim. Let's go to the other side to the mock-up of the next generation plasma.
Thank you, Gerard. Very impressive. But of course we have also do a next step towards scaling up. Sharia, could you explain what our next step is?
Of course, thank you, Hans. So this is the next step that we have. So we want to use an arc plasma to process the gas, the methane gas here. This is the reactor that we have, and that we just generate arc plasma in the reactor. The feed gas is methane and hydrogen that we produce the plasma between cathode and anode. We want to optimize this reactor, so we use a magnetic coil to establish this arc as well. And after that, we have a different modules that comes after. We have a reaction chamber, which we want to cool down the gas temperature. And of course, we have the quenching chamber, which again, we just cool it down more to have the desired product, which in this reactor is acetylene.
And with that acetylene, what are we going to do with that?
So we want to hydrogenate that, and after that, we want, in the pilot plant, we want to produce ethylene.
Okay.
And the next aim of this project, this reactor is to just understand the parameters that we want to scale it up for pilot plant.
Okay, thank you very much.
Thank you, Hans.
Let's walk over to Zoe. Maybe Zoe, you can tell us something about the pilot plant.
Yes, of course, because the next step in the development process is a pilot plant. And what we're going to do, we're going to scale up this 50 kilowatts bench scale setup to a 100 kilowatt setup where we will produce acetylene in the plasma reactor. But that's not the main goal. We want to convert this acetylene to ethylene via hydrogenation step. And the total production of this process, which can also be seen on the screen, is about 3 tons per annual on hydrogen and 12 tons per annual on ethylene. And what we want to do with this pilot plant is to see, well, we're going to combine 2 different technologies. And what we want to do is to see how are these technologies working together and how are these technologies working on the long run. So for example, if we do it for 6 weeks, or whether we run it for a few months, we want to see what's the difference between a bench scale. How is the heat management, how is it working on the material, and that is what we want to study on this bench scale, also because we want to gain knowledge on how to scale up further to, for example, a demo plant. And that's our goal for this pilot.
Thank you, Zoe. So I hope you have enjoyed the tour through our lab. I hope also to see you back here at some point live. If you have plans, ideas, questions, please visit us in the future.
Okay, see you next time.